Okay, so just to finish this up, so when you have two sources that are creating a wave in a medium, really it's not just one-dimensional interference that you can have. If it's a string, it'll be one-dimensional. If this was like a slinky and I was sending a wave down it and you were sending a wave down it and they met, this is what it would look like. But when it's in water on the surface of your bathtub, it would be two-dimensional and the waves would spread out in all directions. So whenever two crests cross, you would get a high peak, and whenever two troughs cross, you would get a really low gully, and anytime a crest crossed a trough, you would get level. That's in a bathtub. If these were two light sources with the same frequency, then whenever two crests or two troughs cross and you put a screen back here, you would get a really bright spot. It's actually the one in the middle is called the central maximum. And then as you go out, this one would be another bright spot, and it would be the first max, and the second max would be down here. And then up here would also be the first max and the second max. But in between them, if you look in the space in between, it's green crossing pink. They're canceling each other out. And so in here would be the first minimum on either side. First min, it would be darkness. And if these two, instead of these being two fingers creating water waves or two light sources, if these were like two speakers at a concert, then you would get the same thing, only these spots where we have maximum, they would be where the sound was the best. And the dark spots in between the minima would be where there was dead sound. Okay? And you've probably been at somewhere where, or it might even be when you're driving in your car. Have you ever noticed when you're driving in your car, you get really clear reception or cell phone service, and then it dies out, and then clear. So when like radios are setting up their two radio towers, or if telephone companies are setting up their telephone towers, they try to make sure the maxima are in the spots where most people are living. And the minimum will be like Durham and Peniac and, where there's a lot of more trees than people. Okay? We'll come back to this when we get to light, and I'll show you an equation for it. All right, a couple of other little definitions before and then we can start sound. One is reflection. And I know you all know what reflection is. Reflection is when a wave is passing from one medium to another, and it hits the boundary in between, and it reflects back into the first medium. Okay? And when it happens, okay, so let's make this our boundary. Okay, and here's our water waves maybe coming in. Okay, so they're striking the boundary as they come in. It's easiest if we draw the arrow that shows the way the water wave is coming in. When it strikes the boundary, the direction of the wave will come off at exactly the same angle as it went in. So this angle is known as the angle of incidence, and I'll write it down there again in a second. And they're going to reflect off at an angle exactly the same. They'll reflect off like this, where this angle is the angle of reflection. So there is a law, it's called the law of reflection. It's the easiest law you'll ever meet. It says theta I equals theta R. Theta I is the angle of incidence. And incidence simply means incoming. So it's the angle of the incoming ray. And theta R is the angle of reflection. The angle, the outgoing ray. And both angles are measured with a line that's drawn perpendicular to the surface that it's reflecting off of. And this line is called the normal. Remember, the normal force was the force acting perpendicular to the surface. So this line is just a perpendicular line. And so lots of times when we're doing light, right, we'll have the light ray coming in, striking the surface, going back out, theta I, theta R. The ray coming in is called the incident ray, and the ray reflecting off is brilliantly called the reflected ray. And again, we'll come back to reflection in light. Okay? But here's the law. Next one is refraction. And I know you know what this is, even if you might not recognize the word. Refraction is when a wave passes from one medium to another with a different density, and the speed changes, and that change in speed causes the wave to bend. You would have seen it if you were ever bored sitting at the dinner table because your parents or whoever keep talking, and so you have your glass of water and you put your knife or your pen or something in it. And so the knife goes down and then it appears to bend. This is refraction. The best way to understand it is to imagine that we're on a beach in Hawaii. And because we're so happy to be on this beach in Hawaii, we're all walking together. So this line is the line between the water and the sand. And here we are, holding hands, walking in a straight line. But as we walk, the people on the water edge end up walking a little bit in the water. And as they do, so we're walking this way, but the people in the water start to lag behind. They can't walk as fast because they're in a different density medium. And so even though we're traveling this way, they're traveling slightly different, right? That was supposed to be, I didn't do a very good job there, did I, at my lines? So, like, hopefully you can tell these lines are in a different direction, going in a different direction than these ones that are going straight up. Okay, so there's a bending. You can see it at the boundary. That is refraction. We'll come back to that in light as well. And then the last one is diffraction. And diffraction is the spreading out of a wave behind a barrier or around an opening. You would have seen diffraction if you were ever lying in your bed at night in your darkened room and someone comes in to get something and the hallway light is on, and when they leave they don't quite close your door. And the result is the light comes in that little crack and spreads out. That's diffraction. If you were to play again in your bathtub with water waves and you were to put, I don't know, something that could block the water, okay, but leave a little opening, and then you put your finger in and out of the water here, as that wave spreads out and gets to this point, what you'll see happening on the other side is this. Diffraction is the spreading out of a wave behind a barrier or around a corner. Okay? We will start sound next.